This video I'm going to do to finish 6.1, all right, section 6.1. We've got two examples that we need to do. One of them is finding the area of an oblique triangle. So just please remember that the area an oblique triangle is a triangle that is not a right triangle. All right, so to find the area of an oblique triangle, I need a couple of formulas. Actually, I only need one, but I have three to choose from. I have these three to choose from. I have, for each of these formulas, I have two sides and the included angle. Okay, so I'm going to choose the one that's going to best fit the information that I have. All right, so here's the example. Find the area of an oblique triangle. Find the area of an oblique of a triangular lot having two sides of length 90 meters and 52 meters and an included angle of 102 degrees. Let me go ahead and draw out a triangle, and I'll label it as ABC, triangle ABC. Okay, that's a C, by the way. It's an ugly looking C, but it's a C. Yeah. All right, so I know that according to our example, we have lengths of 90 and 52. Let's just say this is 90 and this is 52. And an included angle of 102 degrees. This is the included angle. So the included angle is always going to be the vertex shared by the two sides. This side and this side shares this vertex, so that makes that the included angle, and that's 102 degrees. All right, so what do I have? I have side A, side B, and angle C. So side A, side B, and angle C. So I have side A, side B, and angle C. So this is what I'm going to use for this example. So area is equal to 1/2 times, I don't need that yet, I'm going to write the formula down. 1/2 times side A times side B times the sine of angle C. So side A is equal to 90, side B is equal to 52, and the sine of angle C, which would be the sine of 102 degrees. Just multiply that into the calculator, which I've already done. Okay, there it is. So the area of this triangle is equal to 2,288, let's go one decimal place, 0.9 meters squared. All right, so that is example 6. All right, example 7 deals with the application problem, application of the law of sines. Here is example 7. The course for a boat race starts at point A and proceeds in the direction of south 52 degrees west. That should look familiar, but I will explain to you how I draw that out. To point B, then in the direction of south 40 degrees east to point C, and finally back to A. The point C lies 8 kilometers directly south of point A. We want to approximate the total distance of the race course. All right, so let's draw this out. Okay, so first off, this is example 7. I need a point A, so let's call that A. All right, so the race starts here and proceeds in the direction of south 52 degrees west. South, let's draw a dotted line. South is going to be directly straight down. North, by the way, would be straight up. East would be directly to the right, and west would be to the left. So this is south, and we want to go 52 degrees west. So west is going to the left, so we're going to open an angle up to the left, and that would be a 52-degree angle. And we are going to go to point B, so let's call that point B. Okay, after we arrive at point B, we're going to go in the direction of south 40 degrees east. So again, let's go south, straight down. And let's open up an angle to the east. East is going to the left. One thing I do know is that we end at point, we're going to point C, and point C is directly south of point A. So this would be a 40-degree angle right here. Let's call that point C. And the last thing that we know is that point C is 8 kilometers directly south of point A. So I know this is 8 kilometers. I want to find the length of the race, which means I'm basically finding the perimeter of this triangle. All right, so I already know one side. I need to know the other two sides. And also, for me to use this law of sines, I need some more information, because if I look at the law of sines formula, one of these ratios has to be complete. I need to know angle A and side A, or angle B side B, or angle C side C. One of them has to be complete. None of them is complete. I've got angle A, but I don't have side A. I have side B, but I don't have angle B. So you see the problem I'm running into. Now, one of the things that you've learned in geometry or math 2 is you've learned that if you have a parallel line, or two parallel lines, because these two lines are parallel, with a transversal cutting through them, then that has to mean that alternate interior angles have to be congruent. So this is a 40-degree angle also. So this is an alternate interior angle, and so is this. So this is a 40-degree angle. I have that second angle. Now I can find my third angle by subtracting 180 minus 52 minus 40. That gives me 88 degrees. So this is an 88-degree angle. Now I have one complete ratio. So let me go ahead and fill that in. The sine of 88 degrees over 8 kilometers. And I have all the other angles. I have angle B, which is, I'm going to put that 88 in the wrong spot, and I'll put that 8 in the wrong spot. So let's fix that. So angle B is 88 degrees over side B, which is 8. I know angle C is 40 degrees. I don't know side C. I know angle A is equal to 52 degrees, and I don't know side A. All right, so let's just work right here, okay, with this proportion. So cross multiplying, 8 times the sine of 52 degrees is equal to A times the sine of 88 degrees. I'm solving for A, so let's go ahead and divide both sides by the sine of 88 degrees. That means side A will be equal to 8 times the sine of 52 divided by the sine of 88. So it looks like A is going to be equal to 1. No, hang on. I did not hit a button when I should have hit a button. Sorry. Okay, so 6.3. I did not divide. I actually just typed in sine of 88. All right, so A is equal to 6.3 kilometers. I put that in the wrong spot. It really doesn't matter. We'll still get the correct answer, but I want to keep things consistent. Okay, so side A is equal to 6.3 kilometers. All right, so let's go ahead and find side C, which is right here. I'll go ahead and use these two. So the sine of 88 over 8 is equal to the sine of 40 over C, cross multiplying. Divide both sides by the sine of 88. So side C will be 8 times the sine of 40 divided by, I'm making sure I hit it this time, divided by the sine of 88. And I get 5.1 kilometers. All right, so what is the length of the race course? The perimeter of the triangle will give me the length of the race course. So 5.1 plus 8 plus 6.3 is going to be about equal to 19.4 kilometers. All right, so there is example 7, and that completes section 6.1. Okay, so certainly hope that this helps. If you have any questions, please reach out.